Alrighty, what is up, YouTube? What is up, ye? We're back at you with some college algebra. Still on exam 1, but we're doing a new problem today. We are doing 3A and 3B. So let's go ahead and start with good old 3A. So the question is 6x minus 2 times x minus 1 equals 4 times x plus 1. Alrighty, so important things that whenever you're doing this problem, you want to follow PEMDAS. So we're going to go ahead and do that. And our first order is to distribute these numbers out, simply this 2 and this 4. So we're going to go ahead and do that real quick. So I'm going to erase that real quick, kind of make it a little bit clearer. Okay, there we go. All right, so let's go ahead and distribute that out. Alright, so we're going to start the left side first. We're going left to right to be 6x minus 2x. Since it's a double negative here, negative times a negative, this becomes a positive 2, so plus 2. Make sure you bring that equal sign over here, 4x plus 4. Alrighty, a couple important things we'd always like to note of this. Combine like terms first, so boom, boom. It's going to be 4x plus 2 equals 4x plus 4. So we do want to move this x value over to one side and the whole numbers on the other side. So we're going to go ahead and move this 4x over first. We're going to go ahead and minus 4x. Minus 4x, that gets us 0. So 0 plus 2 equals 4. What? Doesn't make any sense. Well, let's go ahead and finish the problem anyways. Minus 2, 0 equals 2. This is in fact no solution. We kind of found that out earlier as we minus this 4x on both sides. That gave us 0. There's no x left over, so we can't really solve for x. So this is indeed no solution. Don't make a mistake I made. Make sure you understand how a number is attached to a variable when you're solving for something like this. I did not get that my first time, so it's important to note. Alrighty, but that's that. Make sure this is no solution. So, and this is going to be your final answer. Yippee! Okay, next one. Let's go ahead and erase this guy real quick. So that is 3A. Let's go ahead and do 3D. 3D is going to look like this. It's going to be... Oh, my bad. 3B. Sorry, I've been saying probably D the whole time. 1 minus 4 over 3x equals 5 over 2. Alrighty. So... couple ways to approach this problem. First off, I want to get this 1 out of the way first. So I'm going to minus 1. I'm going to minus 1 on this side as well. You do have to make these common denominators alike. So we're going to go ahead and make this into 2 over 2. So it's going to be looking like this. 4 over 3x equals 5 over 2 minus 2 over 2. Want to make sure these denominators are alike in order to subtract a fraction. So I just essentially times these by 2 over 2. You will follow the rule of essentially any time you are subtracting a fraction. We'll get more into that and the unique ways that variables interact with that into exam 4. But we're in exam 1 right now, so let's not worry too much about that. Alrighty, so this comes 4 over 3x equals 3 over 2. Okay, so I want to clear this x by itself. I want to get it by itself. So I want to go, let me carry my negative over. My bad. Because the negative carries over. I want to make sure I get rid of this, right? So I'm going to go ahead and times it by the reciprocal of this guy over here to get rid of x. So basically think about it as dividing the fraction, right? Because it's attached multiplying to x, right? And to divide a fraction, get a copy dot and flip that guy. So we're going to go ahead and times this by 3 over 4, negative 3 over 4. Same on this side, negative 3 over 4. This x becomes isolated. It becomes x equals negative 9 over 8. That is indeed your final answer. I'm going to go ahead and box that guy. So, couple important things you know of this problem as we're going back. Pro tip, make sure you understand how to subtract fractions and make common denominators like we did up here earlier. Also do make sure how to kind of clear out a fraction in general. Like I said, times it by the reciprocal, which we did over here. And that gets you our answer right here. Alrighty, cool. Thanks.